I want to spend a few minutes and discuss how you can use a double loop to iterate through every pixel in an image. And I want to do it from a conceptual standpoint. We talked about in another video of how to access the value of a specific pixel using the pillow library in Python. But if you wanted to look at every pixel in an image, it is in 2 dimensions. So you can't just use a one-dimensional while loop or for loop to iterate through every pixel in an image. You have to use essentially a double loop, a 2-dimensional loop, a nested loop in order to accomplish that task. So I'm going to pull out the drawing here a bit. So again, let's just imagine that we have an image and it's a 2x2 image. So remember, X goes to the right, Y goes down. Pixel 1, remember everything is an XY format, so 0, 0, 1, 0, and then 0, 1, and 1, 1. So these are your pixels. And let's say we want to go this direction. We start at 0, 0, and we want to go in a zigzag format and end at 1, 1. So remember, we're going this way, keep going down. Now, how would you accomplish that? Well, you would do a loop where you would go row by row by row. Now, how do you go row by row by row? Well, we can do this using while loops in Python. So we would essentially create 2 counters. Now we need to know what our limits are. So let's talk about this image a bit more. Our width, W, equals 2, so 2 pixels. And our height value is 2 pixels. All right, so those are our limits. The value of X can go from 0 to 1, and the value of Y can go from 0 to 1. So this is where we use the concept of 2-dimensional arrays. So let's write some pseudocode. So here, Y equals 0. So we're going to do Y in the outer loop, and then while Y is less than height, now we do an inner loop, X equals 0, and while X is less than width. And then here we would access the pixel. Access the pixel X, Y. Add 1 to X. Now break out of this block of code, and we'll add 1 to Y. So what are we doing here? How would this work? Well, the first time this loop is run, Y is equal to 0. We jump in, is 0 less than, in this case, 2? Yes, it is. So now we're going to create a variable X. X is 0. Now remember, X is local to this code block. Now is X less than the width of 2? Yes. All right, so first we're going to access pixel 0, 0. That's the first one up in the top left corner. All right. Now we're going to add 1 to X, and we're going to go back up here. Is 1 less than 2? Yes, so now we're going to access pixel 1, 0. All right. We're going to add 1. Is 2 less than 2? No. So now we're going to jump down here, and we're going to add 1 to Y. and we jump back up. Is a y of 1 less than 2? Yes, and we perform this inner loop once again, and we access pixels 0, 1 and 1, 1. Finally, we add another increment y, and now is 2 less than 2? Nope, and we're done. So again, we've accessed this 4 pixel image, and let me draw it out again down here, and we'll traverse it manually. We access it this way. We hit this first, this one second, this one third, and this one fourth. Now, if you want to do it the other direction, we'll create a new slide here. Okay, so let's say we had another 2 by 2 image where x goes this way, y goes this way. This is 0, 0, 1, 0, 0, 1, 1, 1. And let's say we wanted to access the image like so. We start here, we go down, and we end here, right? So width equals 2, height equals 2, x goes from 0 to 1, y goes from 0 to 1. So if we want to access it in this direction, we just invert how we are running the loop. So we start off x equals 0 while x is less than width. In this case, it's 2. Y equals 0 while y is less than height. Again, height is 2. Access x, y. Y plus equals 1. X plus equals 1. So again, we can think of it in the same way we did before, but we just invert x and y. So if we draw this 2 by 2 block again, the first thing we access is 0, 0. That's going to be 1. But now we go down, and 0, 1 is the second item we hit. Then we go back up to 1, 0, which will be item 3. And finally down to 1, 1, which is going to be 4. So in this instance, what we're doing is we're traversing the columns instead of the rows. So we do the first column and then the second column and so on and so forth. If you're writing this in Python, so we've done pseudocode here. So again, if we're writing this in Python, we have values. So we have, let's say, width is a variable, height is a variable, x is our current x position, and our y is our current y position. So these are our variables. We would write it such as this. So let's say we were doing the first method, we're going to traverse starting here this way while, I'm sorry, let me get my trusty eraser. So x equals 0. Erase it again. Y equals 0. So again, we're traversing it that way. While y is less than height, colon, x equals 0 while x is less than width, colon, and then this is where you would do something. Now x plus equals 1. We jump outside of this code block, y plus equals 1. And again, we're traversing the image like this. If we were to write the Python code in the other direction, our variables, again, width, height, x, y, and we want to traverse the image starting from the origin like so. We start with x equals 0 while x is less than width, colon, y equals 0 while y is less than height. Here is where we do something. Y plus equals 1, and then jump out of this code block, x plus equals 1. And again, we're traversing the image down the row to the next column, down the column to the next column, down the column to all the rows, to the next column, so on and so forth. And that's basically it. So again, to access every single pixel in a two-dimensional image, you will want to traverse it using a two-dimensional loop. Now, in SegAnalysis, we talk about applying a one-dimensional list or array to a two-dimensional image. So one more concept we should cover. So here's our problem. We have a two-dimensional array, which is an image right here. 0, 0, 1, 0, 0, 1, 1, 1. But then we have a list. So this is your image. But then we have a list. 0, 1, 2, 3. So let's say we want to write these values to this two-dimensional array, and we want to place list values such as this: 0, 1, 2, 3. Well, how would we do that? Well, first we have to look at the concept of how do we want to traverse the two-dimensional array. Now, if you want to do it this way, you have to traverse it using this method, right? So how do we traverse it using that method? For this method, we have the y value on the outside loop and x value on the inside loop. And then there's one more trick. We have to keep an overall counter. So let me erase these items. And let's write some pseudocode. So here we know a few things. We have width, height, we use x, we use y, but then we also have to have counter. And counter has to increment every time we touch a pixel. So we could write our code like this. Counter equals 0. Now, we also set y equal to 0, because again, we want to traverse the image like this. While y is less than height, Now we have x equals 0 while x is less than width this is where we can do something with counter. So we have a list here. Let's say our variable is called list. List counter would access the current one-dimensional value of the list. And we could do something, right? Do something at x, y with that list item. And then we would do two things in here. We would increment x, but then we would also increment counter. So what this means is every time we touch a pixel, and every time we're at a specific pixel, and we're always at a specific pixel in this code block, we increment the counter by 1 when we're done. Outside of this code block, all we're doing is incrementing y. Y plus equals 1. We're not incrementing counter because, again, we only want to increment counter at a specific x, y value. So what this algorithm does is it allows you to apply something at a one-dimensional array to a position in a two-dimensional array. We could take the same concept and if we had an image 2x2 image 0 0 1 0 0 1 1 1 and we had a list 0 1 2 3 and we wanted to access the list items such that we were going down the columns, so 0 1 2 3. We would use the same concept. We would just flip x and y. So our variables width, height, x, y, counter, and list. Again, counter equals 0. And just to be clear here, now we're going through like this. I talked to it, but we're accessing these items like in the same pattern as we talked about in the inversion, where x is on the outside and y is on the inside. So counter equals 0 while x is less than width. Now what we do is, and I'm sorry, go back a little bit. Before we do that, we have to set our x equal to 0. So counter equals 0, x equals 0, while x is less than width. Now we do y equals 0, while y is less than height. Now we can do something with list. Again, I'm just putting this in a comment. List counter. Do something at x, y with that. And then here again, we increment y plus equals 1. Counter plus equals 1. And then when we jump out of this, this is where we increment x. X plus equals 1. So again, it's just the inversion of what we talked about before. So again, we're applying the one-dimensional list to this two-dimensional image where you have positions every x, y. And we do that through a two-dimensional array, but we have a one-dimensional counter outside of that array, which is only incremented when we have a specific x, y value. So in the second, in the inside loop, in the inner loop. So hopefully that gives you a picture of some algorithms and ways to go about and tasks to go about in terms of accessing items on an image, how you might apply data to a specific pixel when you have one dimension of data and applying it to two dimensions. When we talk about steg analysis, we have one dimension, which is a bunch of bits that we want to put into that image, but we have a two-dimensional image, and we have to do some methods to access that, and we can use this algorithm to do so.